Hello and welcome to Richardson RFPD's Tech Chat. I'm Ray Ragonese, Technical Sales Engineer here at Richardson RFPD, and I'm talking today with Brandon Becker, onsemi's Silicon Carbide JFET Marketing Manager. Thanks for joining us today, Brandon.
Thanks, Ray. Appreciate it. Love being here.
Awesome. Well, cool. Let's jump right into today's topic on solid-state circuit breakers. There's been a recent trend to replace traditional electromechanical circuit breakers with solid-state circuit breakers to protect expensive power electronics equipment. Can you explain the main design differences between traditional and solid-state circuit breakers?
Yeah, definitely. And I just love this topic because I love technology that hasn't changed in over a century. So let me share real quick some of the main differences between traditional circuit breakers and solid-state circuit breakers. But I think it's worth noting kind of how this hasn't changed for so long. If you look, really since the 80s was when the mechanical circuit breakers came out, and it's just a couple metal parts versus today, we're just now coming out with solid-state circuit breakers. And we want to be, driving new products. And there's a few differences between these. We'll start with the parts and the BOM. So traditional circuit breakers have a small amounts of metal throughout them, whereas solid-state circuit breakers have a much higher component count, such as control boards and power boards. The cost of mechanical circuit breakers is fairly low, while solid-state circuit breakers have a higher cost. The good news is that's decreasing. Traditional circuit breakers are dumb. They really don't have any intelligence unless you're adding circuitry into it, while solid-state circuit breakers are smart. There's an MCU in it and has lots of intelligence. Reliability, contacts degrade over time. Additionally, you're throwing a switch, so they are slow, whereas solid-state circuit breakers have unlimited amount of power cycles. They're faster, and faster equals safer. So of course, we need to look into the future where traditional circuit breakers are mature and solid-state circuit breakers are going to be what's driving smart cities. And a few factors that are driving these solid-state circuit breakers, of course, safety, so arc flash mitigation. They're over 1,000 times faster. They have current adjustments, smart functionality, load shedding, and of course, intelligent networking.
Awesome. Thanks for that very thorough explanation, Brandon. So, based on your description, I can see how solid-state circuit breakers would be a more expensive device. I can only assume that there's significant system-level benefits using solid-state design to rationalize the higher initial costs. Can you possibly summarize the system-level benefits that are driving the move towards solid-state?
Yeah, definitely. I see it as three main reasons why we are moving to a solid-state circuit breaker. The first is speed and safety. As I mentioned, there are arc flashes, there are contactors in mechanical circuit breakers. All of those do degrade over time and switching with voltage and load. And speed. So speed is very important when it comes to the safety of devices. The second one at a system level is compatibility. You notice everything is being connected to the Internet of Things, and so should our houses. If you think about it, people that own different houses, maybe rental houses, maybe vacation houses, they can now turn on and off appliances, understand if there's any type of electrical event happening, and they don't have to be there. So remote monitoring, current shedding, as well as just power grid management is where we are going with our grid utilities. And lastly is the standards. I don't know if a lot of people are aware, but there is regulatory standards around semiconductors. Just another interesting system level fact is that at industrial breakers, typically you need safety teams and medical people on site for some of these maintenance. When they're switching a very high voltage, very high current switch, there could be danger. With solid-state circuit breakers, you just tap a button, shuts down the system, safety, a huge decrease in cost in operating.
All right, Brandon, that makes sense. So can you tell us what devices onsemi offers for solid state circuit breakers, and maybe mention any tools such as reference designs, evaluation boards, simulation tools to support customers that are interested in developing their own solid state circuit breakers?
Yeah, onsemi has a number of resources. So starting with just a lot of documentations, videos, blogs. We have silicon carbide robustness. And then we also have our products. So aside from just the protection devices, such as the silicon carbide JFETs or MOSFETs, we also have amplifiers and diodes and gate drivers and internet and ethernet, controllers, Bluetooth, etc. And then we have technical documents such as applications notes and evaluation guides. But two that I want to bring to your attention that are most prevalent is one is we do have an evaluation board. So using our combo JFET solid state circuit breaker, so you can get the schematic and get even a demo board if you would like to. And then we do have an online calculator. So this calculator is designed specifically for circuit breakers or circuit protection applications. We have our AC leakage calculator as well as our CBJet simulator that can simulate your system with your parameters, all online and all free to use.
Cool. So, well, thanks for your time, Brandon. That was really a great overview. We'll take a deeper dive into the specific power semiconductor devices options that onsemi has for solid state circuit breakers in the next text chat in this series. In the meantime, thanks again for your insights and how onsemi can support new designs. We thank everyone for watching our tech chat video. Be sure to access the helpful resources on today's topic from the links in the comment section below our video.
Thank you.
Thank you.